My project is on passive daytime radiative cooling. I think this little image here does a pretty good job explaining it. Basically, they're just little sheets that can be made that reflect incoming solar radiation and long wave infrared. The way it works is that it reflects it in a certain atmospheric window so that it bounces off back into space, basically. So it will cool off both the surface temperature and it will prevent that heat from staying in the atmosphere. Some research into this technology I found was in the city of Kolkata in eastern India. What they did basically was set up a bunch of passive daytime radiative cooling surfaces onto rooftops and a bunch of neighborhoods to study the effects that would have on ground temperature. And it also had some effects on um, humidity as well. And what they found is that it pretty significantly reduced ground temperature under good circumstances. It did overall as well in basically all circumstances, but in some of the results, it didn't drastically change the normal ground temperature very much. So for the environmental impact, like I said before, with the project in Kolkata, it had the potential to reduce the ground surface by almost 9 degrees Fahrenheit, which is pretty significant. The way that this works basically is that all the heat that gets reflected goes and bounces off into space. Just kind of what this picture here is about the global energy budget. Basically, we're now trying to pull out more energy into space than what we're taking in. Basically, we're taking in too much. We're not putting enough out, so we're trying to put a little bit more out. And another thing is that it's also very customizable depending on circumstances. This technology works very well in more arid climates and very hot climates. It doesn't work very well in tropical climates because the efficacy of the technology is hampered by cloud cover and humidity, which are both obviously very common in tropical climates. So for the feasibility technologically, a PDRC surface, 10% of a building group can replace 35% of air conditioning. So it has the ability both to effectively reduce, um, you know, ground surface heat, and at the same time, it can offset other forms of cooling so that it can, reduce cost and provide a bonus basically. Also, is the dynamically switchable coding. So an issue that you might have is, it's great in the daytime if you live in a hot climate to have that heat offset, but at night when it gets colder, that might become an issue to have it, cooling off even more. So you can put on these dynamically switchable coatings so that it's not cooling off too much when you don't want it to be. And likewise, another issue you could have is glare from these very reflective surfaces. And they can also just put a coat of paint on that basically to reduce the glare. For economic viability, this technology is great because it is pretty low cost. I mean, you don't need to, pump a bunch of electricity or energy into it. It's just a surface that on its own can reflect heat. And because of this also, it's pretty simple to manufacture and modify to, fit certain climates because it is so easy to make and simple as an idea that you can add on a bunch of other things to it to make it, adapt to the circumstances a little more. Because it's so cheap and pretty effective, but can also cut costs, with AC running or electricity, fans, anything that you would usually use to cool off that, you know, takes a lot of money or energy. This can offset that by being a pretty cheap and simple alternative. As for its social and political acceptability, I think socially it'll be quite acceptable because um it's very unintrusive. And there's not a whole lot of input that needs to be done in order to produce all of these things. Politically, it could be a little bit more difficult. Like it says here, you would have to dedicate about 1 to 2% of Earth's surface to PDRC to stabilize surface temperature, which sounds, you know, quite good that you would only need 1 to 2% to stabilize the surface temperature, but 1 to 2% of Earth's surface is quite a large area, and to be able to produce that much of this technology would be um, a real feat of political unity. But I think something that could help that is that it is a very large growing market, and it's a fairly simple technology to produce. So I imagine as the market share for it grows and it produces more and more money, I would imagine that it becomes more politically acceptable as, it becomes more profitable. There are still risks and uncertainty that come with this technology, although it is, again, quite low risk, just from the nature of it. Um, there's already a lot of ways to offset risk, like I said, with the ways to cool in to reduce glare. That's what this is right here. It's something that they use to make it not cool off too much at night. But I think it doesn't always greatly reduce temperature. So the amount that you would need to meaningfully reduce the temperature in a while could be a little bit cost prohibitive based on where you are, and that could make it a little bit more difficult to pull the kind of political consensus that you would need to undertake that kind of project. So I think really the takeaway here is that it's a very good technology to use. It's very low risk. There's a lot of potential benefits, and it's fairly easy to produce and to develop further. But the big thing really is that the scale that this technology would be need to use that to make a global impact would be very difficult to meet, I think. It'd be very difficult to pull the kind of resources and political willpower to be able to e- e- develop this into something that would have a global and lasting impact.